Hello, everybody. I'm Giorgio, Regni, CTO of Scality and a co-founder. A lot of familiar faces, some new people, so nice to meet everybody. Today, we're going to zoom on the tech. Before that, I'll show some numbers. And I wanted to start with giving the story of Scality a little bit, the origin story, as I call it. So how do we get our name? So I think Paul talked about it at the beginning a little bit. We used to work with large service provider at a previous company. So people like Comcast, Cox, Time Warner Cable, Orange, KDDI, SoftBank, and go back to 2008, and they had issues with storage. And so we asked them, "What's your biggest concern?" Well, we do compete with Google and Facebook. Google at the time, Gmail was 1 gig per mailbox, and Comcast was 20 megs. Mm-hmm. Comcast was using financial grade SANs, like a large, beefy, purpose-built server. So the same tech you would use to store financial data in banks was used to store pictures of cats and PowerPoint jokes, because email was that in 2008, right? So you have to do something different. So they look at what Google was doing, what Amazon was doing, S3 was started, and it was all cheap servers, cheap drives. Let's put all of them together and give you an infinite pool of storage. So they say we want the same thing, but we have no developers to build it. So it wasn't our business, storage wasn't our thing. So we looked at, should we sell somebody else? Look at some of the tech we could reuse, and nothing was there. We looked at a lot of solutions. Ton of startups at the time trying to solve that problem. So then we said, should we build our own? And I was, no, I don't want to do that. When we looked at it, and we looked at some papers, like Dynamo papers, we looked at all this, and it was very interesting to us. And finally, we decided, because we keep hearing about no single point of failure, scale out, infinite pool of storage, ability to scale in any dimension. And that sounded great to us as French engineers. So we decided to jump into this and started a POC. The POC was successful. We signed a service provider in Belgium called Telenet, and we jumped into the storage business. We had a lot of ideas. We didn't have a name for the company. And it's very frustrating when you have ideas and all the names are taken. So what I did is I generated an algorithm based on all the characteristics that customer wanted, like infinite ocean of storage. Find some names, so it find 1,000 names, try to make them scalable and available, and who is searches and stuff. And we finally ended up with 10. The company voted, and Scality won. So why Scality? Because scale, this is our definition, the ability of a system to expand seamlessly across all critical dimensions. So not just one dimension, all the dimensions that matters. And in the presentation from before, you heard about more metadata, more capacity, more throughput. These are all different axes, and we know how to scale in all these different axes independently. So this slide coming next scares me. There's too many points, so I'm not going to go through each of these. Instead, I'm going to show some numbers, and then I'm going to show some examples from customers and also contrast to competition.
It used to be Scality RING elements were all similar. I mean, they were all doing the same functionality. It seems like you've disaggregated.
So it was always disaggregated. So
it was.
Day one, we had the storage nodes, talks to the network. It's the only thing it does. Then we had the IO daemon, only talks to the disk. And they communicate via a fast communication internally. Think of it as NVMe over fabric, but inside the machine, all shared memory type of thing. And that was already day one inside the box. So some customers decided to split that afterwards, right? We also had a connector layer on top. And we did that because that's the way we think. We think microservices.
Right.
And then as we went into issues in production, it's a good idea, we can move that service to another machine. And that's when we got the idea to make that more easier to manage, right? But it was already disaggregated, day one. Some numbers. So in production today, we have 12 exabytes of data. But maybe 15 talking now. Amazon is 400 trillion object. Sorry. I'll talk about object after. This is just the capacity. That's around 500,000 drives. So we know a lot about drive failures. We know how to change a drive, when a drive is going to fail, what's happening on the platform. This is the number one issue that people have. So network is a big issue. Drive failures happens all the time. across all our customers, I would say there's at least 10 drives that fail every day, right? But the system is constantly trying to rebuild and fix these kind of issues. We have around 6 trillion objects stored on the platform. AWS is 400 trillion. So I'm like, maybe we work 3% of AWS, just 3%. But the market doesn't agree yet with me. A single customer, we talked about it today earlier, has 300 billion objects. Then we also work with a lot of intelligence agency, and another one has 150 billion objects. These numbers, there's no limit to how many objects you can have on the same platform. The mean time to failure is 5 years. What I call failure is losing service for more than 5 minutes.
Mm.
Okay? And so a customer, we get one event every 5 years. That's on average. So it's always up, another way to say that. One customer has more than 2,000 applications. What we call an application is an S3 client that we don't know about. So some of them are ISV partners. Some of them are just homegrown applications, and there's a lot of homegrown applications talking into the system. Our customers are service providers, a lot of them. So then we have end users. And if we count all the end users, we are around 700 million users using our product every day. They don't know they're using it, but it's actually Scality in the back. Performance-wise, so a single cluster, there's an example, it could do more, but 60,000 S3 operations per second. I'm talking about full operations, of the entire get, put, delete info. So that's 12 million IOPS on disk, if you were to count the actual disk operations. 80 gigabytes per second read is 2 sites, so it's actually 160 gigabytes per second across 2 sites. How do you do that? You have to parallelize everything, because TCP has window size issues. If you were to do one connection at a time, you will get a very low performance. If you were to do a big object one at a time, it will be very slow. So we split things up and try to make it as parallel as possible over the wire. Typical latency, we use hybrid flash and drives most of the time. So flash for metadata, drives for capacity. That gives you between 2 and 5 milliseconds latency. What I call latency is time to first byte. So if you have a 100 megabyte object, it's going to take longer to copy the entire object. We recently released a full flash solution, and now you're looking at microseconds latency, right? And people need that today, especially in AI. So
how do you get all this data? Are you actually able to look into customer environments, or are you just asking them what they're seeing?
No, so some customers we can't, so we know the contract, how much capacity they have bought. Other customers, we actually get feed from the customer, and we use that for stats. Let's look at some examples. Now, we had a lot today. These are some more. So look at this axis. We call the number of applications. Aurelian talked about this bank that has more than 2,000 applications. That means, what does it mean? It's multi-tenancy. So none of the apps see the other app's data. They're all separated. We have QoS, so quality of service. We know that one application is not going to impact the other one, right? They have limits into what they can do. We also do all the utilization tracking. So this tenant is consuming 10 terabytes. They should not go more than 20. All of this we track in the system. That's what we mean by multiple apps. It's actually the multi-tenancy in the back. And a lot of our customers want to build their own customers, even if they're internal or external. So we do all the usage tracking. So you consumed 100 gigabits per second. You burst it to 1 terabit per second. All this data is fed so that you can do your own internal or external billing. Another example is the number of buckets. So typically, you would think that you don't need that many buckets. So most of our customers do 1 bucket, 1 customer. So Orange has 35 million mobile subscribers, so that means 35 million buckets.
Wow.
When we designed the system, we never thought somebody will abuse buckets this way, but actually they all do. So we had to design a specific bucket metadata engine that can scale to these numbers. And when we started, we had this distributed ring system, and the metadata was not as scalable as the ring system. So you could design this crazy system that scales automatically, but the metadata was not at the level. So we worked a lot to make it as multi-geo, redundant, failover replication as the actual engine. Then the scale. So Amadeus is an airline service provider. They do all the booking, editing boarding passes, this kind of things. So they're a customer of ours. They have to log everything for compliance. And for us, that means a petabyte a day of logs. So we're ingesting a petabyte per day, and these are not big files. So it's a lot of operations on the platform.
Can I ask a question, please?
Yes.
Disaggregated architecture, is that microservices or
You
is it
can call it
different
microservices.
from
Yeah.
the microservices?
In disaggregated, there's a notion of efficiency where you're not copying the data around, so it's logically disaggregated, but there's some optimization in the data path. But yeah, it's kind of microservices. So this is, I'm going to try something, okay? So the market is very noisy these days. Everybody does everything. Everybody is the best object storage. Everybody does all the AI that exists on the planet, even though we don't see the actual project, but I digress. And everybody is the best. So I wanted to compare to other systems. So I don't know, let's see what happens. So let's compare to a Ceph. So I'm looking at actual documentation online, okay? So we talked about we can scale to hundreds of billions of objects per bucket. So the actual official Ceph documentation say, if you have more than 100K objects in your bucket, you will get performance degradation. So that works for some customers, that doesn't work for others. And that's things that requires a lot of work to go past these kind of limitations. Simply because they don't have a metadata database, so they have to do a lot of things in a non-scalable way. But that's one difference, right? Another difference on Ceph side, we talked about how it's decoupled. We have a disk daemons, we have the network daemons in our system, we have the connector layer. Actually, the connector layer is 3 different things that you can scale independently. So that allows you to do these things where a customer, Iron Mountain, you could see that he had only 36 S3 nodes and 120 storage nodes. So it's all fully decoupled, sizable way you want. That helps you scale to exabytes of capacity. Yeah? We don't have one customer where at that scale, they need the exact same number of storage nodes that they need of connectors. There's always a difference at that scale. Let's look at MinIO. So we told you many customers have one bucket, one end customer. So Orange was 35 million bucket. In MinIO, you would go to 500,000 buckets per cluster. That's a good number, but there's a limit into how many buckets we can create. In our design, there's no limit to how many you can have of anything. The fact that I love MinIO for being lightweight and easy to deploy on one machine, on one container. What this means is it's one big monolithic component. And you don't have this flexibility of how you want to scale it. They don't have a database either, so an object is a file, metadata is a file. That means listing is going to suffer because you're doing directory operations as opposed to database indexed lookups like you would do if you have your own metadata engine. So I don't know if it's useful. I just wanted to contrast some differences. I'm not saying something is bad or better. I'm just saying there's difference. It's not all the same. Okay? The layers. So many different types of applications connect to the Scality system. Then you have this connector layer. So XDM is our internal. When you talk about lifecycle management, tiering, expiration, that's the XDM layer doing this. It can also talk to the cloud, talk to Google Cloud, to AWS, to Glacier, both the S3 service, for example, but also the cold storage service. So Azure Cold, Azure Warm, and so do some tiering of data to the cloud. Then you have the S3 protocol we've been talking about. There's also our internal REST protocol, which is much more lightweight. That's what we use internally. And we give it access to customers who ask for that level of performance. So AI, like Weka is a partner of ours in AI, they go through the internal API. They don't want the S3 overhead. We support file system connectors. We have our own file system metadata engine that's distributed on the cluster. And we support SMB, NFS, CDMI. We all wanted CDMI to succeed, but it's an object interface on top of file. And Fuse. Fuse is when you want to mount directly on your actual application and don't go through the NFS or SMB overhead. So all the file system connectors are on the same namespace. Then you have the actual storage hardware. And as we discussed, both layers scale independently. You need a management interface.
What do you mean by two layers are scaling independently?
So that connector layer can be on different servers, can be on virtual machines if you want to.
Oh, okay.
And then you can add as many as you need if you need.
Right.
And the storage nodes, these are the actual servers with flash or drives or QLC flash. You can scale them without having to scale the connector layer. So you need more capacity, you add servers at the bottom. You need more client performance, you add more servers at the top.
Okay. And so what are the requirements for the servers, for the compute? Like, is there like, NVMe or like what is?
Yeah, so there's two kinds for the compute.
Yeah.
Some parts of the connector are stateless, so we don't need anything. So no need for drives. Just give me CPU and memory.
Right.
Okay? Some of the connector layers actually need some flash for metadata. So you would do NVMe or you would do fast flash for them. Still with a lot of compute and memory because the connector needs that. For the storage node, we don't need a fast CPU, but we need a lot of drives.
Yeah.
So we would find servers with 100 drives, 90 drives. You will find QLC boxes with a petabyte in 1 2U box today. That's that layer, the storage nodes.
And it needs to be like, nodes. So you can't use like, external storage or anything like that for
Oh yeah, when I say node, I'm kind of simplifying. The node could be a small server plus expansions in the back. And then you add capacity by adding enclosures of JBOD. That's one way to do it.
Oh, so it can be like external storage? So it can be like okay.
Yeah.
But it's a JBOD storage.
Yeah.
It's not like a storage system.
Oh, no, it's a JBOD. It's not another storage system.
Yeah.
Oh, I see. Okay.
Yeah.
What about the metadata? Where is the metadata stored?
So in that picture, it's on the storage nodes.
I'm sorry, it's on the what?
It's on the store nodes. The metadata in that picture, that is something that you can decorrelate as well, And we have customers with the metadata on different servers than the storage.
So it's effectively distributed throughout the storage nodes in some cases, but it could also be consolidated to a couple of storage nodes. And is high availability for the metadata part of that, or how?
Yeah, it's the same as the data. We follow the same.
So
principles.
depending on the customer's erasure coding requirements, the metadata would have the same erasure coding requirements as the data.
Yeah, metadata is a lot of time replicated, so you will not go to 12 parities. You will go 5 because that's enough if you are replicated.
Yeah.
That makes sense?
Yeah. That's actually a good point. So like how this can be distributed, like, let's say the connectors and the storage hardware layer, like, are there any like latency requirements between each other or like, can be?
Yes. So if you do one ring on one site, they will be on a fast network with each other, right? They will be on a 10 gig, 100 gig on a fast network. You could decide to move a connector close to the application. Okay, but you need enough bandwidth to the ring, but you don't need the 10 gig that I talked about.
So there are no latency requirements between the connectors and the storage hardware?
Apart from your application requirement. If you want 1 millisecond latency at the application level, you're going to have a 1 millisecond network. If your application is not latency sensitive, then the connector don't have to be on a fast network.
So where are metadata stored? And then
on the storage.
On the storage nodes.
What is the most common bottleneck you see in the architecture from a customer perspective? Are they not buying enough drives? Don't have a good enough network, not enough compute in the connector?
Yeah, so the multi-site would be the biggest problem.
Multi-site?
Yeah, they want to replicate in less than 2 hours, but there's only 1 gigabit per second. That's the number one thing. Say, we can try, but there's no chance. There's the network failures. So it's not that we don't have a capacity, it's that the network is unstable. That happens all the time.
How do you avoid in the multi-site, like, the split brains and stuff? Like, is there any, like, third?
Ooh, so I have another presentation for that.
Oh, okay. We're going rabbit hole. Okay.
Yeah.
Just high level, like, there's like something where
So the ring itself is based on CHORD, C-H-O-R-D.
Yeah.
Which is a peer-to-peer distributed system. So none of the nodes have to know about each other. They have to know about 5 or 3 to 5.
Right.
So they maintain communications with his 3 to 5 servers. And as long as they're alive, they think everything's happy, everything's fine. and they don't need to communicate to anybody else. So that really simplifies the network traffic.
You don't have weakness, basically.
No, yeah. There's no single point of failure. There's no node that's better than the others. There's no masters, no slave. They're all part of this peer-to-peer system. This I can present at one of the other tech field days if you want. I have the slides for that. Any other question on this?
The supervisor is not replicated. The management monitoring.
So it is.
It is.
Yeah. So
it's just not.
Yeah, but that slide, yeah, should make it better. Yeah, the supervisor is not a single point of failure.
Okay.
That's a good question. This is the architecture for our largest customers. Okay. So I'm not gonna present it yet. I'm gonna go through some simplified version and then build up to this architecture. If you have ambition to get it to an exabyte, that's what we're gonna deploy. Okay.
So the Ring XP, is that just designating all flash, or is there actually anything different in?
It's all flash, and you have access to our internal APIs to use Ring XP. So I will go back to Ring XP after. So this slide. So if you have one site, you know, I think we talked about it. I don't know if I can walk to the screen. Is it following me? Yeah, maybe. So you have your different apps connecting to the system. Then you have the S3 protocol. I'm focusing on S3 right now. We give you one global namespace across the entire system. We do connect to your internal directory for users, like Active Directory, LDAP, whatever you have, for single sign-on. We support multi-factor authentication, everything that you would need for security. And that goes into the connector layer. This is what we call the S3 metadata engine, and the drives in your site. And these are the two layers that you can scale independently, as we talked about. And that will be a one-site deployment.
So in this case, the metadata is on the connector nodes, not on the storage nodes? Is that hard?
No, so that is a storage node. The S3 metadata is here. The connector is actually here. So the connector
they're all storage nodes in that block there. I see. I got
the connector runs without any metadata, uses the storage servers for metadata along with the drives. Okay. Then if you add multiple sites, then you have this component of lifecycle management that comes into play that can manage transitions, replication, expirations between sites. Okay. It uses the same metadata, so it has the same capability of scaling and data protection for its own configuration. And that is all managed into the global namespace at the S3 level. Okay? So we talked about bucket configuration for replication. If you follow the S3 protocol, that's all you need to do. And we manage it in the back, all the policies.
This is working on your hardware, like on the hardware with the software. You don't need any external virtual machine or anything to bring these functions.
No, correct.
It's just implemented inside the stack.
Inside. So,
but you said on the upper layer, that's where you can run it as a virtual machine.
You could run it. We don't need it, but if you want it, you could run it as a virtual machine.
Yeah, but you can run it on a bare metal as well.
Yes. Yeah.
Okay, but that's overkill a little bit, isn't it?
And
so if you want only compute, if you only need compute because you disaggregated the architecture, you would do virtual machine. It's much easier.
Yeah.
The connector nodes are split across sites, or they're connected? I don't. How are the connector nodes? How are they distributed across sites?
So the connector nodes, if I remove the metadata part, only the connector part, they don't have any state. So they don't need to know about anything else. So you just add connectors as you need more connectors.
So they could be anywhere.
Yeah, be anywhere.
Stateless.
We love stateless. Then you build up this to the full end-to-end architecture where you add the hot tier with XP. So the flash would be NVMe, TLC, very fast. There's no drive on the XP side of things. Then we have the tape support that we discussed with CNES as an example, where it could be one site, it could be multiple sites. We can do Y applications to two sites. We can do all the policies of expirations through Glacier, cold storage API, all of that is managed from the same ring.
So
yeah, go ahead.
So the Ring LT, it's a future feature.
No, we have that today.
Okay. And
Ring LT means long-term storage. It's existing.
Okay, but so basically you have the module inside the software you have that can be distributed as well on this bare metal or hardware part, but as well moved to the VM. And this is the middleware that it's connecting to IBM or wherever, HP tape libraries,
like,
or needs something in the middle.
DMF, Atempo,
So
IBM.
there is no need for any additional software. It's just that, and it's doing the tiering automatically.
Yes.
Okay, and the same way it's going for Glacier, for example, AWS Glacier, right? So you have another module which is connecting to the AWS Glacier, right? And you push the data there.
Right.
Okay.
One for me. So my understanding, right, that the Ring XP, Ring, and Ring LT are like different S3 endpoints which you can access, or the intelligence is happening in that, like, you know, in that orange layer.
Okay. So Ring and Ring LT are the same namespace. They're not a different system. So you have the same endpoint. XP is going to be a different endpoint because typically you want maximum performance. It makes no sense to go for the same endpoint.
Yeah.
So XP will be close to your AI nodes, for example.
Right.
On the same InfiniBand network. It's not going to be shared with.
And can you extract that endpoint for the LT, let's say?
Yes.
Yeah.
Then they're part of the same namespace, but on a different network.
Right.
That makes sense.
Okay. Yeah, that makes sense. Yeah.
If you do the XP directly going for a low-level API, then you're stuck on the machine. There's none of the multi-tenancy works anymore because you made a decision to get maximum performance.
Can you have a multi-LTL support? So you have two sites, for example, two data centers, and in each one you have the LTO, and then you drop the data on the both LTOs in the same time.
So yes, that's something we've done already.
Okay.
I thought you were going to say multiple tech of tape, different vendors. This I don't know. We could, but
nobody will want to risk that, right? Yeah. But I'm saying that, you know, just if you have two data centers and then you are protecting yourself from burning out the HSM solution. Okay.
I think I have 5 seconds left. Is it what I'm?
What's the distinction between site 0 and the 3 replicated sites on this slide?
Oh, because it's the full flash site. It's unique.
It's full flash, so it's not replicated. It's not. Yeah. It's there for.
Typically, you're not going to do any fancy replication on that one. It's all for pure performance. I finished with a picture of our UI. And am I completely out of time, or do I have? Yes. I'm done. Thank you very much.